everyone, welcome back. We are on lesson 10 right now, and we are going to be discussing Pythagorean Theorem today. Quick heads up, you may want to have your calculator for this. We're going to be dealing with square roots, and while yes, you can leave them in square roots, they have to be simplified if you do, so sometimes it's just better to just use your calculator, put it in decimal form, and just be done with it. So let's get started. Okay, so first, before we start working with our formula that we know for Pythagorean Theorem, let's prove why it's true. Pythagorean Theorem only works when you have a right triangle. And basically what that is saying with Pythagorean Theorem is that the legs of the right triangle, which are the two sides that are adjacent to this right angle, the legs squared will equal this part, the hypotenuse squared. So I'm going to help you guys see this a little bit closer. So if I were to take 3 squared plus 4 squared, I should get 5 squared. And for our visual people, I kind of drew it out. So 3 squared is 9. And 4 squared, if you were to count all of these squares, is 16. And 5 squared, 5 times 5, is 25. So 3 squared is 9. Plus 16 equals 25. And in your calculator, if you want to check your work, let's make sure that this is a true statement, and we'll find out it is. So instead of working with 3, 4, and 5 for our formula, we're going to work with something else. So for our formula, we're not going to use 3, 4, and 5. We're going to use variables. And we'll say A and B and C. And in this case, for establishing the formula, A and B are my legs, and C is my hypotenuse because it is the longest side of my triangle. And so we write it as A squared plus B squared equals C squared. And this is something that we will use for the rest of this year, so make sure that you remember it. Okay, so let's do some practice. With this right triangle, we see that our two sides that are adjacent to a right angle are A and 4. Before I start working with all this stuff, I'm going to go ahead and write my base formula. A squared plus B squared equals C squared. And I'm going to replace A with this A plus, and then instead of B, I'm going to write 4. And instead of C, I'm going to have 7. Okay, and so from here, I'm just going to simplify, solve, and get A by itself. So A squared stays, plus 16 equals 49. Trying to get A by itself, so I'm going to get rid of 16 by subtracting it. And then A squared equals 33. And so now A is still not by itself, it's being squared. And the way that we undo a square, or we do the inverse operation, is to square root. So I have to square root both sides. So A equals the square root of 33. Or I can get out my calculator and I can hit second x squared, which brings up my square root, 33, enter, and this is going to be 5.74. And they don't tell us the unit of measurement, so we just leave it as units for either one of these. Both of these answers are correct, so either one will work. Okay, our next example gives us 2 points on a coordinate plane, and it says they want us to use Pythagorean Theorem to find the distance between these 2 points. So what I'm going to do is I'm going to take this and make it be my hypotenuse, and I need to create the 2 legs of my triangle. Okay, so now I have a right triangle, and I want to ask myself, how far up did I go when I had those 2 values? And I know that to go from 2 to 4 is the distance of 2. And then going from -3 to 4 is a distance of 7. So now I have the measurements for the 2 sides, the 2 legs of my right triangle, and we're going to call this part C. So working with our formula, A squared plus B squared equals C squared. I'm going to replace A with 7 plus, and instead of B, 2 equals C squared. So we have 49 plus 4 equals C squared. 49 plus 4 is going to be 53 equals c squared, but c is still not by itself, so I need to square root both sides. And c equals the square root of 53, and we're talking about a graph, so units, or 7.28 units. And that's it, we're done. All right, and that's it for lesson 10, working with Pythagorean Theorem.